This is a video from section 3.3. Number 1, the limit as theta goes to 0 of sine theta over theta is 1. Number 2, the limit as theta goes to 0 of 1 minus cosine theta over theta is equal to 0. A couple things I want you to note. If I take the limit as theta goes to 0 of theta over sine theta, I get 1. And the limit as theta goes to 0 of cosine theta minus 1 over theta is equal to 0 as well. Now, I have a claim. The limit as theta goes to 0 of tangent theta over theta is equal to 1. Now, remember that tangent theta is equal to sine theta over cosine theta, right? And so I can rewrite this limit as follows. This is equal to the limit as theta goes to 0 of sine theta divided by theta cosine theta, which is equal to the limit as theta goes to 0 of sine theta over theta times 1 over cosine theta. That's right here. And so I can break this up as follows. So this is the limit as theta goes to 0 of sine theta over theta times the limit as theta goes to 0 of 1 over cosine theta. So this is equal to 1 times 1 over cosine of 0. But remember that cosine of 0 is equal to 1. And so this limit will end up being 1. And so therefore the limit as theta goes to 0 of tangent theta divided by theta is equal to 1. Now, let's go ahead with that in mind. Take a look at number 51. If I have the limit as x goes to 0 of tangent 2x divided by x, okay? Now, same idea, you want the argument of the tangent, which is 2x, to match what's in the denominator, which in this case is just x right now. And so what I need to do is I need to put a 2 in the denominator, but I can't just do that. And so what I need to do is multiply this limit by 2. Why? Because 2 over 2 is 1, and anytime you multiply by 1, you don't change the value. So this is 2 times the limit as x goes to 0 of tangent of 2x divided by 2x. Now, what I'm going to do is I'm going to let theta equal 2x. Now, theta goes to 0 as x goes to 0, right? Therefore, 2 times the limit as x goes to 0 of tangent of 2x divided by x is equal to divided by 2x, right? And so this is 2 times the limit as theta goes to 0 of tangent theta divided by theta, which is equal to 2 times 1, which is equal to 2. Therefore, the limit as x goes to 0 of tangent of 2x divided by x is equal to 2. That's number 51. I want to take a look at 55. Suppose I have the limit as theta goes to 0 of sine theta divided by theta plus tangent theta. Okay? Now, I'm going to do something sneaky on you. So I'm going to take the limit as theta goes to 0, and what I'm going to do is I'm going to divide the numerator and denominator by theta. So in the numerator, I get sine theta divided by theta, And in the denominator, I get theta plus tangent theta divided by theta. Okay? Now, I'm going to take the limit of the numerator and divide by the limit of the denominator. So this is the limit as theta goes to 0 of sine theta divided by theta divided by the limit as theta goes to 0 of theta plus tangent theta divided by theta. Now, right away, we know that the limit in the numerator is equal to 1. So I'm going to put a 1 there. And I'm going to divide by the limit as theta goes to 0 of 1 plus tangent theta divided by theta. And so all I did was split off that fraction. And so this is equal to 1 divided by the limit as theta goes to 0 of 1 plus the limit as theta goes to 0 of tangent theta divided by theta. And so this is 1 over 1 plus 1, which is equal to a half. And so therefore, the limit as theta goes to 0 of sine theta divided by theta plus tangent theta is equal to a half. That's number 55. If we take a look at 57. Suppose I had this one. The limit as theta goes to 0 of cosine theta minus 1 divided by 2 theta squared. Now, what I'm going to do for this one is multiply the numerator and denominator by the conjugate of the numerator, which in this case is cosine theta plus 1. So what I'm going to do first is multiply again by cosine theta plus 1 in the numerator and the denominator, like so. Now, this is the limit as theta goes to 0 of, in the numerator, we have cosine squared theta minus 1. In the denominator, we have 2 theta squared times cosine theta plus 1. Now, remember that cosine squared theta plus sine squared theta equals 1. Now, sine squared theta is 1 minus cosine squared theta. But we have cosine squared theta minus 1. So I'm going to multiply both sides by a negative, right? And negative 1 specifically. And so negative sine squared theta is cosine squared theta minus 1. And so this is the limit as theta goes to 0 of negative sine squared theta divided by 2, and then I'm going to replace theta squared with theta times theta times cosine theta plus 1. Now I'm going to pull a negative a half out in front of the limit, okay? And so we get negative 1/2 the limit as theta goes to 0 of. Now I'm going to get sine theta times sine theta Now, if you don't mind, I'm going to put a 1 up here. And then I'm going to divide by theta times cosine theta plus 1. And so this is negative 1/2 times the limit as theta goes to 0 of sine theta over theta times the limit as theta goes to 0 of sine theta over theta times the limit as theta goes to 0 of 1 over cosine theta plus 1. So I broke it up in this way. And so this is negative 1/2 times 1 times 1 times, now remember cosine of 0 is 1, 1 plus 1 is 2. So we're going to multiply by 1/2. So to evaluate that third limit, it's just direct substitution. And so the answer to this problem is negative 1/4. And so therefore, the limit as theta goes to 0 of cosine theta minus 1 divided by 2 theta squared is negative 1/4. And I want to take a look at problem 58. Suppose I had the limit as x goes to 0 of sine of x squared divided by x. Now, just like before, you want the argument of the sine, which is x squared, to match what's in the denominator. And it doesn't yet. And so to accomplish that goal, I'm going to multiply the denominator by x. But I can't just do that. And so I have to multiply the numerator by x. So I'm going to do that. I can't move an x outside of the limit. Why? Because we're limiting on the x. It's not constant. Okay? So you have to be careful there. And so if you notice, we got the limit as x goes to 0 of x sine of x squared divided by x squared. So this is the limit as x goes to 0 of x times the limit as x goes to 0 of sine of x squared divided by x squared. The limit exists, so I can break it up accordingly. So the first limit is 0, and then I'm multiplying by 1, right? And that is, I do claim that is 1. If we're not sure, I can show you how to evaluate that one. But this is 0 times 1, which is equal to 0. And so, therefore, the limit as x goes to 0 of sine of x squared divided by x is equal to 0. And let's make a quick note here. I'm looking at the limit as x goes to 0 of sine of x squared divided by x squared. Let theta equal x squared. Now, theta goes to 0 as x goes to 0, right? And so this is the limit as theta goes to 0 of sine theta divided by theta. And that is indeed 1. So that's why I got 1 over here. All right, that'll conclude this video for section 3.3. We worked on problems 51, 55, 57, and 58. Okay, thank you.